NASA's James Webb Space Telescope is cooling down for its next trick, observing the universe. Mankind's growing need to explore space is providing the basis for modern inventions, exploration, and research. The leading space company, NASA, has held the honor of initiating and successfully conducting numerous space missions. They are also the leaders of research and invention as far as space is concerned. They have many space-related inventions to their account, including the famous Hubble telescope. The Hubble Space Telescope is a 31-year-old solar-powered spacecraft. Its aims and tasks include exploring the solar system and the surrounding space and sending back to the Earth the information it has gathered in the form of pictures. With the help of the Hubble Space Telescope, NASA has been able to locate and study many black holes, measure the age of different stars with a 10% accuracy, observe the size and growth of the Milky Way, take into account supernova reappearances, and do much more of what goes over the top of a normal human mind. These studies and observations have provided the scientists with sufficient information to back new theories, discover the age of the universe, and solve astronomical mysteries, all while discovering new ones. But the Hubble Space Telescope is not really what the launchers wanted it to be, and that has led to the launching of Hubble's successor, which aims to achieve in 10 years what the Hubble has not achieved in 31 years. Why is this, and why was Hubble unsatisfactory? Well, stick around and you'll find out. Before we move on, don't forget to subscribe to our channel and click the bell icon for regular updates on the most recent space adventures and technological advancements. What went wrong with the Hubble Space Telescope? When the telescope was first launched, there was a manufacturing error in the Hubble Space Telescope. It was discovered when the telescope sent the first few pictures it had captured in space. The images were blurry and unfocused. The problem appeared to be so profound that it not only affected the clarity of images but also their color. However, when the problem was discovered, it was a very small one. During the polishing process, one of the main mirrors had been grounded the wrong way. Its edges were flattened just a little more than needed, leaving the mirror unable to focus. The flaw was minute, at just 1/50th of the thickness of the sheet of paper, but that was a big enough problem to cause major imaging issues. This problem is called spherical aberration. A team of NASA experts went into space via a space shuttle in 1993 to fix the issue. This became the first space repair mission, and will always be remembered and discussed when the history of man's adventures into space is discussed. But it was not the first and last problems of Hubble. The first space repair mission was the first in a series of many, all for the Hubble Space Telescope. Then on 13th June 2021, the Hubble Space Telescope unexpectedly shut down. NASA troubleshot this glitch and first thought that this has happened due to an aging memory. However, later observations showed that there was a problem in Hubble's power control unit. The solution to all this Hubble bubble, pun truly intended, was to turn on the backup hardware as there was a problem in the payload computer. According to the experts at NASA, this was a very risky task. Paul Hertz, the NASA director of astrophysics, said, "If you do it wrong, you can leave the spacecraft in a situation where you might not be able to recover. So you want to make sure you don't do it wrong." He went on to add that, "I think that's the level of care and risk that we want to be aware of as we move forward." 5 weeks later, the backup hardware was turned on successfully and the telescope was up and running again. Even though the problem was solved and Hubble's full glory was restored, one thing had been very clear to the space enthusiasts since the very beginning. If they wanted to continue to explore any more space, the Hubble Space Telescope would need a successor, and this had to be sooner than later. This was where the James Webb Space Telescope comes in. The telescope has been underway for a long time and was finally launched on 25th December 2021. The James Webb Space Telescope. Named after NASA's late James E. Webb, who remained their administrator from 1961 to 68, who was involved in much of Apollo programs. The James Webb Space Telescope was originally supposed to be launched in 2007. Its development has been underway since 1996. However, due to recurring cost overruns, a redesign in 2005, multiple technical problems including a ripped sunshield during a test, multiple communication glitches, and the COVID-19 pandemic, the telescope was not released before 2001. Even though the construction of dear old James was complete in 2016, it could not be released before extensive testing. However, all this delay was not in vain, because when the telescope was finally released, and once it was finally up and running, NASA described its launch to be flawless and perfect. Why is the James Webb Space Telescope a suitable successor to this Hubble Space Telescope? The first and most evident function of Webb that gave it an advantage over Hubble is that it orbits the Sun while Hubble orbits the Earth. The point of orbit of Webb is the second Lagrange point, or L2. It is 1.5 million kilometers away from the Earth, and the telescope is positioned in such a way that it also stays in line with the Earth while it moves around the Sun. This also means that the telescope's sun shield provides sufficient protection to it from the light and heat of the sun, the Earth, and also the Moon. Due to this difference in orbits, Webb will be able to cover a larger distance than Hubble did and will also be able to map a larger area of space than Hubble did. Secondly, the Hubble Space Telescope used visible light and ultraviolet wavelengths to observe objects in space, while the James Webb Space Telescope uses infrared wavelengths. This means that the Webb will be able to view objects in space that are 100 times duller than the Hubble could detect. Physics says that a shorter wavelength means a heightened resolution and sensitivity for not just telescopes, but for all imaging objects, including microscopes. So by using Webb, we'll be able to see clear images of space, and observers might be even able to find something new that they have not been able to discover in the previous years of space technology. These are the major features of the James Webb Space Telescope that give it an advantage over the Hubble Space Telescope. There are other more scientific features as well that will only further confuse the common mind and are best left for astrophysicists to explain. But for the record, one feature that the Webb has that NASA's website states is that Webb will have an approximately 6.5 meter diameter primary mirror, which would give it a significantly larger collection area than the mirrors available on the current generation of space telescopes. Hubble's mirror is much smaller at 2.4 meters in diameter, and a corresponding collection area of 4.5 m2 gives Webb around 6.25 times more collecting area. What's going on now? Because the James Webb Space Telescope is using infrared wavelengths for imaging, it must stay incredibly cool. All those who have been to elementary school must know that infrared wavelengths are directly related to heat. This means that if the telescope or any of its parts come too hot, it will interfere with the imaging or totally stop imaging. So on 6 January 2022, the telescope deployed its radiator into space so that it is held slightly away from the main body of the telescope. This way the heat is produced and it does not interfere with the imaging and instead lost in space. So it can be said that the radiator is cooling down. Once it is cold enough, we will finally be able to view space in a new light, literally. The whole process will take approximately 5 months to complete, but what will come after seems very promising. John Mather, a Nobel laureate and astrophysicist who also works at NASA's Goddard Space Flight Center in Greenbelt, Maryland, addressed the media during a live-streamed Explore Mars event on 3rd February 2022. According to him, one of the jobs that will be done during these 5 months is the combining of images from the 18 hexagonal elements in the telescope's primary mirror. First, we will have to find images that all of those 18 different hexagons are making, then figure out which one of them is which, and then start sending commands to the little motors that move the viewers around to get them in the right place, he said. He promised that the telescope will be used to explore objects closer to the Earth, too, such as Mars, Jupiter's moon, Europa. Due to this, we'll be able to explore these regions for habitable features. This means that we'll be one step closer to the noble goal of most space endeavors, to develop military and strategic advancements against other countries. Just kidding. Even though that could be a goal of space exploration, the major goal that everybody has been talking about lately is to take man to inhabit other planets as well, and the development and launch of this new telescope is a major leap where this goal is concerned.